Today we're going to be looking at something we call the distributive property, and I'm going to show you why we learn this. So first of all, we have been taught order of operations. And in order of our operations, if you remember, we have PEMDAS, which means that you always do the parentheses first. So if this were a problem on your paper, you would probably look at it and say, oh, I have been taught to do parentheses first. And so you would do 12 plus 4 equals 16. And then in your last step, you would do the multiplication. That would be following the order PEMDAS, which is not incorrect. But what's going to happen when we get into algebra is that we're going to have unknown numbers that we represent with variables. So instead of having something that looks like this, you might have something that looks like this. Okay? Now when you have a variable inside that parentheses and you say do parentheses first, well, I can't add 12 to an unknown number. So I need another way of simplifying this so that I don't have, since I cannot do that step. So we're going to show how this works without variables first, but it's the same process. Now, of course, again, let me repeat, you could do this following your order of operations, doing parentheses first. But we're going to practice a different technique called the distributive property because you will need it when there are unknown numbers with variables. So the way the distributive property works is that you are going to have a set of parentheses, and inside the set of parentheses you're going to have at least two terms separated by a plus or minus sign. Outside that set of parentheses, you're going to have a number, right here is the 5, but there is no multiplication symbol in between. So in algebra, we understand that if there is no multiplication operational sign, that it's multiplication. So what this says up here is 5 times the sum of 12 and 4. Now for the distributive property, what we're going to do is you're going to take the term that is outside, the 5, and you're going to multiply it times every term inside one at a time. You're supposed to be multiplying 5 times the sum of those numbers, but we're going to break it down and take it one step at a time and multiply 5 times each term within the parentheses. So that means that in the first step you would be doing 5 times 12. This is a plus sign right here, so we're going to bring that sign down right here, plus. Then we have 5 times 4. So you're multiplying the term outside times each term inside the parentheses one at a time. When we do this, 5 times 12 is 60, 5 times 4 is 20, and the answer is 80. Now, did we get the same answer had we done our parentheses first? If we had done parentheses first, that would have been 5 times 16, and 5 times 16 is 80. We resulted in the same answer. We're just using a different technique that you will need to have when you have unknown numbers. So you're multiplying the outside term times each term inside the parentheses and bringing down the sign, and then you follow your order of operations. So let's try this again. Now sometimes this looks a little different because the term outside of the parentheses is actually behind it instead of in front of it. It still works the same way. It's still 8 times the difference of 12 minus 3. So you're going to take that term that's being multiplied, which is 8, and you're going to multiply it times each term inside the parentheses, and you bring the sign down. So if we were to do that with this particular equation, that would be 8 times 20 and 8 times 3. So we write 8 times 20 and 8 times 3, and whatever this sign is, this was a minus sign, we have to put it in between. Now let's just stop for a minute. Remember the commutative property. I said 8 times 20, but this says 20 times 8. Remember with the commutative property, it doesn't matter what order the products are, you're going to get the same result. So don't be caught up by that. Now 20 times 8 is 160. And we're going to subtract 8 times 3, which is 24, because we always do the multiplication next, because we do have to follow our order of operations. Multiplication becomes before subtraction. Then we subtract, and we get 136. Okay, now, this is why we learn this, is because sometimes you have an unknown number called a variable, and you cannot do parentheses first. You can't add 5 to an unknown number, so we can use this technique. 4 times the sum of x and 5. So we're going to multiply the term outside, which is 4, times the first term, which is x, and 4 times x is simply 4x. Then we're going to multiply 4 times 5, and 4 times 5 is 20. So that leaves us with 4x plus 20. Now, we have to remember what we've learned about like terms. We can only combine what we call like terms, which means terms which have the same variables attached. This term is being multiplied by an unknown number, which we are representing with x. So this is the step we would have to do next in our PEMDAS. We would have to multiply before we add, but we can't multiply because we don't know what the unknown number is. So this term does not have an x on it, so these are not like terms, so this is as far as you can go. You have to stop right there. Okay, so again, here we go. Let's practice this over and over again until we get really good at it. We have 2 times the sum of a plus 6. We're going to multiply first the term outside, which is 2, times the first term inside, which is a, and that would be 2a. Then we're going to multiply 2 times the 6, and that would be 12. So we have 2a plus, remember whatever this sign is, whether it's addition or subtraction, that's the sign we're going to bring right here. 2 times 6, which is 12. So that leaves us with 2a plus 12. Again, these are not like terms. They would be like terms if the 12 had an a. That would be the same variable attached. Because they do not have the same variable attached, they are not like terms, and we are finished right there. Negative 9 times the difference of n minus 7. Again, we're multiplying negative 9 times the first term, which is n. That would give us a negative 9n. And then we're going to multiply negative 9. And notice this negative sign right in front of it. If you were to add the opposite, you can just look at that and see that as a negative. We're multiplying two negatives, a negative 9 times the negative 7. When multiplying with two negatives, it becomes a positive. So that would give us a negative 9n plus a positive 63. Again, these are not like terms, so that's as far as we can go, and that's your final answer. Okay, we're just going to practice this a few times. I call this the speed round. So you look at this and see if you can multiply that in your head. Think about what the answer would be. So here's what I would be doing. 4 times d in my head, I would think, okay, that's 4d. 4 times a negative 3, look at the sign in front of it, is a negative 12. So I should be able to look at that and say that is 4d minus 12. Okay, you try this one. Okay, so first we do negative 7 times e, which is a negative 7e. Then we have a negative 7 times a negative 4. 2 negatives make a positive, so that would be plus 28. Negative 7e plus 28. How did you do? Let's try another one. Here, the negative 3 is at the end, but you could imagine it, if it makes you feel better, you could write it up here in the front. It's the same thing. You're still going to multiply negative 3, the single term, times both terms inside the set of parentheses. So that would be negative 3m minus 15, because we multiplied negative 3 times m, and negative 3 times a positive 5. Try this one. Did you get 40 plus 8n? First we had negative 8 times negative 5, which is a positive 40. Then we had negative 8 times a negative n, which is a positive 8n. Remember, when multiplying with two negatives, it becomes positive. So think of this subtraction sign right here as a negative sign for that next term. Try this one. Did you get negative 18 plus 6y? We had 6 times negative 3, which is negative 18. And we had 6 times y, which is simply 6y. So it's negative 18 plus 6y. Try this one. Again, the 9 is at the end, but you're still going to be multiplying it times each term inside the parentheses. Did you get negative 36 plus 9k? 9 times negative 4 is negative 36. 9 times k is plus 9k. Try this one. The answer is 10 plus 2p. First we had negative 2 times a negative 5, which is a positive 10. Then we had negative 2 times negative p, which is a positive 2p. I hope that helps with the distributive property, and we will be practicing this on our assignment today. So let me quickly show you your assignment and do a couple for you. In the first section, first of all, we're doing the first 3 columns. The 4th column is going to be bonus. In the first set of problems on this paper, notice that there are no variables. So yes, technically you could do parentheses first and then multiply it times the term outside, and you're going to get the same answer. But we want to practice this distributive property technique because you're going to need it in algebra. So we're going to look up here, and here's how you're going to show your work. 8 times 50, so I'm going to show that I'm going to multiply 8 times 50 plus 8 times 4, and then I can simply do the math, and that would be 400 plus 32 equals 432. So here's how you show your work. On the next one, 4 times 400 is 1600. 4 times a negative 2 is minus 8. So if you want to do it this way, you could actually skip this step if you want to. You could do the 4 times 400 and write that down, the 4 times negative 2 and write that down, and then you would write the answer, 1592. Okay, now when we go down to the next part of the paper, let's see if I can get this to scroll down. This is where the variables are. So first I'm going to do 4 times d, which is 4d. Then I do 4 times 2, positive 2, which is a positive 8. So hopefully you can get to these mentally, and that's the only work you need to show. 3 times x is 3x. 3 times negative 7 is minus 21. Negative 1 times 2 is negative 2. Negative 1 times a negative y. 2 negatives make a positive. That would be a plus 1y. But the 1 can be invisible, so we just say plus y. So down here on this part, hopefully you can just do these mentally and practice your distributive property. Good luck with the assignment.